the live teletraining. It takes about 25, 30 minutes or so. Then we can we'll have time to ask them, questions about the product and just using it potentially in the in the warning decision-making process. On Tuesday, there were quite a few questions, and then once those are completed, we can talk about how the offices and the forecasters can send myself feedback. I'm going to send out a survey, a pretty short survey that is done through the developers in the regions. It's 10 questions. All of them are point and click, basically, other than I think one or two. So it shouldn't take more than a few minutes to complete. And we can talk about other ways to provide feedback. So I think it's a good time to just pass it over to Scott, and he can take it away for about 30 minutes.
Okay, thanks. This is the latest training module on the NOAA ProbSevere. If you used it last year, the difference this year is some lightning observations have been added. So I believe one of the developers, Justin, is also on this call, so he'll be helping me with questions at the end. Okay.
Excuse me, this is Cleveland. Would you mind speaking louder if possible?
I'll do my best.
Thank you.
Okay, so this is, on your screen right now is what the ProbSevere looks like when you have it loaded up. You're getting a shapefile. AWIPS is getting a shapefile and it's displaying a shapefile. If you turn on sampling, you can see everything in there. So it's going to be monitoring a particular radar element. It's also telling you something about the satellite information and the lighting information that went into that. So in this particular case, the ProbSevere on that particular storm has increased. ProbSevere is the probability that the storm will produce severe weather in the next 60 minutes. So that's the metric that you're getting when you look at this, and it's something you should be using before you issue your polygon. So something that helps you become a little bit more confident that now is the time to issue the warning. Maybe ProbSevere, so you've been looking at other parameters, and ProbSevere should just be confirming what you have, what your gut is telling you about the particular cell that you're looking at. It is derived from environmental conditions and observations. The environment is coming from the rapid refresh. So there's an MU CAPE and effective bulk shear. I'll be going over those in a little bit more particular in a bit. The observations there are two satellite growth rate observations, a radar field, and a instantaneous total lightning and effective bulk shear field. So those are the observations that are used. At the bottom there is a link. I think Chad will be sending this around in one of his emails, but there is some more information online about this product, so it's a little bit more in-depth than this particular training. But it is a statistical model that's driven by observations. It's not predicting cloud growth, but it observes what's going on, and based on those observations, it gives you a statistical probability that within the next 60 minutes, will this cell produce severe weather or not? The data the model are using is, so it uses rapid refresh data to set the storm environment. It's looking at the early growth of the particular cell using satellite growth rates, both the cloud top cooling and how the cloud is glaciating with time. Radar imagery is used to, first of all, the radar object is going to be tracked, and that's part of the display that you'll see in AWIPS. But it's also using the MRMS mesh to give you an indication of the updraft strength of the storm intensity, and the storm flash rate is in there as well from the total lightning. I show this satellite image, and as a meteorologist, I'm sure you've done what everybody else has done, and you've aggregated all those clouds into a feature. And what this ProbSevere is doing is it's tracking these features, so the cloud growth rates of these features are computed, and they're monitored from time step to time step with the feature tracking. And when eventually a radar cell grows underneath that developing cloud, the satellite growth rates are passed along to that radar object, and I would say it inherits them, and then the ProbSevere is using all of the observations. So the rapid refresh day, again, it's The effective bulk shear is being used, and also the most unstable cape. It's actually a blend of 5 different times in the model, so three different model runs are used. What it does, it takes a maximum value and then it smooths that value spatially, so you're getting really an overestimate maybe of the storm environment, or the most favorable convective environment for the storm based on the most recent model runs. And again, this is coming from the rapid refresh. And again, there's a link down there at the bottom for more information on exactly how this is done. The satellite data that are used, if you look in eastern Kansas here, you will see the development of a cold cloud top. So we're looking at the cloud top cooling to tell you something about how fast is this cloud initially going up in the atmosphere. And it's also looking at the glaciation rate. So again, in eastern Kansas, we see initially all water-based clouds transitioning to supercooled and then to ice clouds. So that glaciation rate is also telling you something about how quickly the storm is evolving. And a storm that's evolving more quickly, the probability that will produce severe weather within the next 60 minutes, which is what ProbSevere is telling you, is going to be a little bit higher. The radar field that is used in this is the maximum expected size of hail from mesh, the MRMS mesh, that is, which is derived from the severe hail index. And new this year are the total lightning flashes from the radar objects. Now, you may have heard or you may have observed that sometimes the ENTL lightning is dropping out in ellipse for one time period for 1 minute, then it comes back kind of the next minute, then it's back for good in the following minute. That is the lightning that's going to ProbSevere is not the same. Well, it's the same lightning field, but the lightning field that's being used for the ProbSevere is not being affected by this AWIPS-specific data dropout. So even though you're seeing the lightning dropping out in AWIPS, the lightning is not dropping out in the ProbSevere computations. So the nice thing, one of the reasons ProbSevere was developed was to kind of minimize the amount of data flow going into the office, because we all know bandwidth is an issue, and it's not going to get any better in the GOZAR era. But ProbSevere is combining all these different sources of data, maybe a little bit over a gig of data in 1 hour, but the amount of data that's being pushed over the satellite is pretty minimal, 6 megabytes during 1 hour. So that's very manageable. That's giving you some information to help you in your warning decision making.
Excuse me a minute.
Yep.
I'm sorry to interrupt. This is Mount Holly. We're having trouble connecting via GoToMeeting. Did you change the link or send out a different?
There was a new link sent out by Chad yesterday.
Hey, Al, this is Dave. I'll forward it to you.
We didn't get it.
Oh, Dave Riddell? Yeah, okay, yeah, send it to me, please.
It's in the calendar invite, too.
Oh, okay, thank you.
Yep.
Sorry about that.
No
worries.
problem.
If you turn on sampling in AWIPS, all of the information that is going into the product becomes available, which is pretty handy, because then you can, as you look at this through time, you can get a feel for, is MU cape, what's the impact of a lot of shear? What's the impact of a lot of MU cape? If you have strong versus moderate versus weak vertical growth rates, how does that affect the ProbSevere? So I'll just kind of quickly step through what kind of values you have here. So we have the ProbSevere values listed out. Then we have the two model fields, the MU cape and the environmental shear, the bulk shear. Then the MRMS size and time. So typically the time there, you'll notice, is 2204, and that's also the time of the ProbSevere. Typically those two times match. So, then we have the vertical growth rate and glaciation rate. These are two satellite growth rates. That 5.6% per minute, that satellite has detected that the cloud has grown 5.6% of the troposphere per minute. and it's quantified as well, weak, moderate, or strong. So that's very strong satellite growth rate. The glaciation rate is also quantified there. What's the conversion from water to ice clouds at the cloud top per minute, quantified there as moderate. There's an object ID in there, and also the flash rate. There is a lightning jump shown as well, if you're familiar with the lightning jump algorithm. But that is not used in the ProbSevere computation of the probability. It's just kind of there for reference. If you go to HWT, or if you're familiar with HWT output, there are some subtle differences because the HWT AWIPS is a bit more nimble than the WFO AWIPS. So HWT actually has a flash rate printed out separately. In the WFO, it's combined with the object ID, but all of the same kind of information is in the WFO as is at HWT. A couple of quick examples. This is one up over South Dakota, just to the west of a moderate risk. So if you look at this is at 1644. Look at the cape and the shear there. So for highly sheared environment, not a lot of cape, modest cape I'd call that. Low mesh and low lightning. The ProbSevere here at the beginning is 27%, and you'll notice when you look at the sampling that there is no satellite growth rate in this particular case. So either this is a system that has grown spectacularly in the last 15 minutes, which is a possibility, or there might have been clouds that were interfering with the satellite observations of the early growth of the cumulus. That's at 1644. At 1646, you'll notice the ProbSevere has doubled in those 2 minutes from 27 to 54. And a big reason behind that is now you do have satellite growth rates that are very strong. So the vertical growth rate is strong and the glaciation rate is strong. Comparing the flash rate between 1644 and 1646, it's increased from 1.5 to 8.3, so there's an increase in lightning. So all of those different things are driving the increase in the ProbSevere for this particular storm. So you'll notice it's highlighted this one storm, this one isolated storm in southeastern South Dakota. 2 minutes later, ProbSevere is up to 78%. The mesh is increased. The flash rate continues to increase. So all the things, all these observational parameters, so the flash rate and the mesh the times of those are the same time as the ProbSevere observations, but you'll notice the vertical growth rate and the glaciation rate were a couple minutes earlier, and as it steps forward in time, as you get farther and farther away from that vertical growth rate just remains from this one particular observation. So it's the strongest growth rate that you see in the early growth of this particular convective cell that's carried forward with time, and that's something you'll see very frequently with a ProbSevere output. Sorry, step backwards there. So this is at 1648. About 30 minutes later, the ProbSevere has been maintained mostly, and it's at 85%. So it's at 1726. Sioux Falls issued a warning at 1726, and there was a golf ball-sized hail report at 1732. So again, the ProbSevere is telling you what's the probability that this storm will produce severe weather in the next 60 minutes, and it's keyed on this particular cell, and this cell has produced some severe weather. The question always comes up: what information does the satellite provide? So these are on the left. We have the ProbSevere with satellite. And radar and lightning. And on the right, we have the ProbSevere without the satellite, but with radar and lightning. And with the satellite, you have much earlier, you achieve higher ProbSevere values with the satellite. So without the satellite, the ProbSevere only gets up to 65%. With the satellite, it's up to 85% by the time the storm is producing severe weather. So it is giving you statistically valid information about the probability of severe weather. This is another example from just a categorical thunderstorm day. We have, this is 2:10 UTC, so just after sunset, we have high shear and very strong warm advection for this particular case. And again, you see that there is no satellite growth rate with this particular storm at the beginning. And as we step forward in time, starting out with ProbSevere of 9% to 23%. That's driven mostly by changes in the mesh. That's at 212, so we've gone from 210 to 212 to 214. Still no satellite observations here. ProbSevere is up to 46%. Mesh has increased to 3/4 of an inch, and the flash rate is increasing. That's at 214. Then at 216, we do have satellite growth rates that came in at 215Z. And you'll notice the ProbSevere has jumped from 46% to 81% for this particular storm. That's at 216. 222 ProbSevere is up to 94%. The mesh has continued to increase. The lightning has continued to increase. So all these different observational parameters of this cell continue to increase, and the ProbSevere continues to increase. That's at 222. 238 ProbSevere is up to 97%. There's a report of severe hail, and the severe thunderstorm warning was issued 3 minutes later. Another case from Louisiana from earlier this year. So a high shear moderate cape event where we have ProbSevere initially here is at 31%. Again, we don't have satellite. We have a strong vertical growth rate there, but we do not have a glaciation rate with this one. This is 1838. 2 minutes later, ProbSevere has gone from 31 to 52% as mesh has increased, lightning has increased. I'll just toggle between the two of those so you can look at those observations. So we have you'll notice that the normalized vertical growth rate here is from 17Z. So this particular radar cell has inherited that growth rate from an hour and a half ago, and that is a observation that helps the statistics here. It's a statistically valid observation that helps force the ProbSevere to be a little bit larger, as it should be. So a little bit later, we have ProbSevere up to 69%. So 1840 to 1842, then up to 1848, ProbSevere is at 85%. Lightning is continuing to increase. The mesh is up to about an inch. Then we have it up to 93%. So the question, even if you're looking at this in your office, the question is, do I issue a warning on this particular cell? So this is at 1854. Then by 1912, the mesh has dropped a little bit, so the ProbSevere has also dropped. So the mesh has gone from 1.3 inches at 1854 to 0.98 inches at 1906. Flash rate is still pretty high. That's at 1912. At 1924, the ProbSevere is back up to 91%, and there's a 1-inch hail report at 1925. And the severe thunderstorm warning was issued at 1928. On the same day, we had there was a cell up to the northeast in Mississippi where the ProbSevere was only 5%. Satellite growth rates were not available. The mesh was not very high. The flash rate was 10 flashes per minute. But this there was a severe warning with this 6 minutes later, and it produced a severe wind event a little after that. But even though the ProbSevere is only 5%, because this particular storm did not have, it did not have good satellite presentation. So that was not driving the ProbSevere up. The mesh was not particularly high, and yet it still produced severe weather. So I guess a cautionary tale to not expect ProbSevere to give you to catch every single storm, I guess, is the bottom line.
This is Cleveland.
Yep.
Is this technique most favorable for predicting severe weather from large hail? And what's the story with downburst detection?
It is it was developed for just severe weather. So the statistics were developed in mind for just producing severe weather. There was no separation out of a type of severe weather. I know part of the goal and the development of this in the next couple of years is to separate things out to maybe tornado, severe probability of tornado, or probability of hail, or probability of wind. If you remember what goes into the environment here, there's no helicity, for example, so you might not expect it to be able to do a good job of I guess I I'm going to retract that sentence. There's no helicity in here, so you shouldn't specifically be looking for severe weather in the form of a tornado. So I don't know if that answered your question, or if it answered a different question that was good enough, but as I said, ProbSevere as it was not developed with a specific severe weather event in mind, but more of just a general severe weather.
If there's cirrus from an upstream storm obscuring, rapidly growing cumulus, then that will degrade the technique. Is that so?
That's exactly right. If you cannot see the satellite, if you cannot get the satellite growth rates there because of upstream cirrus, either from convection or just the jet stream, if you have a thick cirrus shield and you can't see growing convection underneath it, that does mean you will not have the satellite growth rate. So you have to temper how you view the field or use the field based on what the environment looks like. Yes. These next two cases document what the impact is of including the lightning as a new predictor in the ProbSevere. So lightning was added to, in this particular case, to screen out those kinds of storms that form in very high cape, low shear environments that go up and come down. They might have the mesh might become very large, but because they're in a very highly sheared, they're not in a highly sheared environment, it's unlikely they're going to produce severe weather. But if you look at this without lightning on the left, which is to say the old version of ProbSevere, the ProbSevere on this left is going to get much larger than the ProbSevere on the right, which has the lightning in it. So on the left we have a ProbSevere of 17% versus 1%. As we step forward in time, ProbSevere gets up to 53%, up to 76% because the mesh is up to 1.33. There's a little spike in lightning with this. The shear is very low, so the ProbSevere, the new version of ProbSevere, is only 11%. So this is screening out a lot of what I would call false alarms that were coming from the old version, which was just looking at the shear and the mesh, and it was giving you a much higher ProbSevere event than was warranted in these high cape, low shear events. Another event that's impacted by the lightning events, this is one in the upper Midwest from 2014. We have a convective element developing into QLCS with a lot of lightning, also a lot of shear. So the ProbSevere without lightning is too low in this case, 36% versus 90% in the new version with high lightning and high shear, which increases the probabilities. So this one had a ProbSevere of 90%, and it did cause some damage over southwestern Wisconsin about the time of this particular image. Some statistics on this. This is comparing the National Weather Service forecaster in blue with the model, the ProbSevere model. This is for looking at the first severe weather report associated with each storm. So ProbSevere is looking for the probability that a storm will produce severe weather in the next 60 minutes. This particular statistic is looking, did it first produce severe weather in the next 60 minutes? So this is the probability of detection unless the Weather Service Office does better. The probability of detection is higher, the false alarm rate is lower, and the critical success index is higher. What the ProbSevere is giving you, though, is giving you a lot more lead time, 19 versus 33 minutes. So that's why this is a tool you can use to maybe have a little more confidence to issue the warning, because it has so much more lead time than maybe the human forecaster than the human forecaster has. Here we have the probability threshold so this is skill scores versus the probability threshold. So this would be a ProbSevere 50%, 60%, 70% along the x-axis. And you'll notice with the old version without lightning, You slowly increased up to about 80%. With the new version with the lightning, there's this very nice plateau between 50 and 80%, which means you can use any probability in there between 50 and 80%, and your CSI is going to be about the same. So you can choose whether or not you want to have a lower false alarm rate to a higher probability of detection versus a lower probability of detection, lower false alarm rate, but you're still getting the same kind of critical success index with that. There are also these are showing reliability diagrams. If you are right along the blue line, you have a perfect forecast. To the right of the blue line is an over forecast, and to the left of the blue line is an under forecast. So the configuration without lightning was under forecasting for all probabilities. The configuration with lightning, you move much closer to a better forecast. So there's still some over forecasting, especially with higher probabilities, but it's better. So there's, as it says, there over forecasting still exists, but to a lesser degree. And you can do that as a function of MU CAPE and effective bulk shear as well, which is in this slide. And again, to the right of the blue line, to the right and down, to the right and below the blue line, you're over forecasting, and to the left and above the blue line, you're under forecasting. So you can see that this model is doing best. That is to say, it's closest to the blue line for moderate amounts of bulk shear and moderate amounts of MU CAPE. If you don't have a lot of bulk shear, you're typically over forecasting for all types of MU CAPE. If you have very strong effective bulk shear, there are cases where you're under forecasting for all types of MU CAPE. So some limitations. One of these we've talked about already, the thick cirrus shield. You'll typically under forecast because you don't have the satellite observations in there. Linear convective modes, this limitation has been helped with the inclusion of lightning. But if you have a linear convective node without a lot of lightning, you're gonna be under forecasting. As I also mentioned, tornado genesis is not represented in the predictors, so keep that in mind. And of course, something that will be mitigated when our data are flowing. We still do have the every 3 hour there's a full disk scan, so the satellite growth rates, those satellite trends during that time will be too weak typically. So it doesn't give you a guidance to every type of severe hazard. It doesn't provide lead time for every storm. It is using goes west data now, so if you're in the western part of the central region and you have, say for example, goes west is in RSO, so it's sampling better and getting better satellite growth rates, those will be the growth rates that are used. So the decision, it looks at both the growth rates from goes east and goes west, and it takes the larger of the two. That's both for cloud top cooling or satellite growth rates and for glaciation. So again, this is something to use to help you get a little bit more confident that the particular storm you're monitoring or looking at is one that's going to produce severe weather in the next 60 minutes. There are a lot of references that you can go through. So John Centineo here is lead author on 2 of them in the past couple of years, so that would be the name to search on if you're looking for this. There is more training that you can go to at this particular website. So the links that were shown periodically in the training all branch off of this particular one. There are ProbSevere blog posts from the Hazardous Weather Testbed at the Hazardous Weather Testbed blog. The developers are listed up on top here, and I guess that's all. I'm willing to take any other questions you have.
Does anyone have any questions for Scott?
Hey, this is Steve at Blacksburg. This is really great information. Thank you. And I don't know, maybe this is a question for Josh at Eastern Region as we're getting the data through the LDM feed, but I've noticed when I'm sampling an AWIPS, what I don't seem to have is the lightning information on the readout. Would there be a reason why I'm not getting that? I don't have an object ID either, but I have everything else.
I'm wondering if you have the latest, something had to be tweaked in your AWIPS.
Hey Steve, this is Mike in Wakefield. Yeah, there was something that was sent out, I forget, a week or two ago regarding that. I can forward it to you. Yeah, this is Justin, UW Sims, one of the ProbSevere developers. Our AWIPS 2 team here sent some instructions out to Chad to distribute to all the ITOs. Just a simple little configuration. Flag needs to be changed in the ProbSevere config from false to true, and then that readout will display.
Yeah, folks, this is Dave Riddell from Eastern Region. Please search the SCP for ProbSevere. You'll see the latest color tables and the menu fix, along with Jerry Wiedenfeld's initial install instructions. So everything is in one spot. Please check out the SCP for that update.
Great, thank you.
Any other questions?
If there's no other questions, this is Justin from Sims. I just wanted to share a quick word and thank everybody in the Weather Service who's taking part of this evaluation. ProbSevere is something that's in development right now, so your feedback is important because we're in the research process, and I think the output I hope you find useful for your day-to-day work, and I think things are only going to get better. So we welcome any constructive feedback you have, and as Scott alluded to. As we look towards next year and the following year after that, we hope to break things into the 3 hazard types and bring in more radar and more appropriate NWP information. But even though where we're at now with just the general severe, non-severe, we think we've shown that it's going to be hopefully a useful tool.
Chad, I don't know if you're still on. Did you want to say something about the feedback mechanism?
Yeah, I am here. So what we've been telling participants in the first training session on Tuesday is that we're going to gather feedback from the forecasters and the SUs through from the masses. We're going to send out a forecaster survey. I should be able to send all that information out within the next hour or so. I was halfway through putting the email together. It's relatively short, as I said. It's about 10 questions, and it just will allow us to gather as much feedback as possible from the masses. For those of you who have discussions with your forecasters or use the product in operations and want to provide us some more feedback by either putting a short PowerPoint together, etc., that's already been done. Some SUs have already sent us little mini cases. Feel free to email us that, and I will obviously compile that as well. And I think maybe in a couple months after the convective season is rolling, after the East Coast starts to get involved in more convection, it'll probably be good to touch base on a conference call and potentially share some ideas. I will most likely send out a bunch of discussion questions that we can talk about. Just so everybody has a way to share their experiences. At times, the developers will write blog posts. I will be sending some of those out this afternoon. Just for mini cases again, and it's just it's a way for all of us to, beyond this teletraining, to continue strengthening our understanding of really how ProbSevere can be used in the warning decision-making process. Because although it's been evaluated at HWT a few times, that's a very safe environment. And the feedback that was gathered there for the product developers was obviously very important and crucial. But this is a new layer of evaluation, actually potentially using it to make decisions and provide confidence in those decisions in the field. So I think those are the ideas behind the ways to gather feedback, and I will send out more information about that within the next hour or so. Does anyone have any questions on anything with the evaluation whatsoever? obviously we want forecasters using this that are comfortable using it. So if that means if they're the warning forecaster and they want to integrate it, that's great. Or if that means a mesoanalyst or someone else that's looking at the environment feeds that information to the warning forecaster, that's good as well. So there's some different avenues. We just don't want to. We want to make sure that this is not forced upon anybody. It's only with a level of comfort. Excuse me.
And this is Scott. Just let me add that there are additional training opportunities. Chad's going to send you around the articulate that I made for HWT, but there are also live visit teletrainings on this topic each month. So you can find the visit teletraining, and if you want to join one of those, you're welcome to do that.